Everyone, welcome to my YouTube channel where we make the learning of mathematics easy and exciting. Today we are diving into a fundamental topic, types of number, as you can see on my screen. Mathematical numbers are all around us, but have you ever wondered how they are categorized? Stick around for the next 10 to 15 minutes as we break it down step by steps. First of all, we are going to look at what are numbers, or what is a number. Numbers are the building blocks of mathematics. They help us to count, to measure, solve, and analyze problems. So, understanding the different types of numbers enable us to solve mathematical and practical problems efficiently. What are the different types of numbers? Let's explore the main types of numbers, starting from the basic to the more advanced categories. Types of numbers are one, we have the natural numbers, zero, whole numbers, integers, rational numbers, irrational numbers, real numbers, and the complex numbers. So what is a natural number? Natural numbers are the first numbers we learn as kids. They are also called the counting numbers. So our basic counting numbers, which start from 1 and end at infinity, are called the natural numbers. Examples are 1, 2, 3, 4, 5, 6 to infinity are examples of natural numbers. Natural numbers are all positive numbers only. Zero is a unique number, a class of its own that requires special considerations. So we have to be very careful when we are using the number 0. You see, 0 is neither a positive number nor a negative number. That is, 0 does not have either a positive or a negative value. You see, 0 acts as a dividing point between the positive numbers and the negative numbers on a number line. And it's also a reference point as well. The next type of numbers we'll be looking at is your whole number. Whole number include all natural numbers plus 0. Example, as you can see, is 0, 1, 2, 3, 4, 5, 6, and so on. The whole numbers are all positive numbers only. A whole number does not include the negative numbers. Integers expand our whole numbers by including the negative numbers. So the positive and the negative whole numbers, including 0, are collectively called integers. Integers, as you can see, is -4, -3, -2, -1, 0, 1, 2, 3, 4, up to infinity. So 0 is the dividing point between the negative numbers and the positive numbers. And it's also a reference point where we are making any measurement. Next, we'll be looking at rational numbers. Rational numbers are numbers that can be written as a ratio or a fraction, where both the numerator p and the denominator q are integers, and the denominator is not 0, are called the rational numbers. So if we have p over q as our fractions, where p and q are integers, and the q, which is our denominator, q, is not equal to 0, are called rational numbers. Example, as you can see, is 1 over 2 minus 3 over 4 the number 5 and not 0.25. Any decimal number that terminates or repeats is also a rational number. If, for example, we have 1/2, which we know that the answer is what? 0.5. You can see the decimal terminate after. Also, if you have 7/8, which is what? 0.875, the decimal terminates after the 3 digits. This is for a terminating decimal. So this is an example of a rational number. What about a repeating decimal? For a repeating decimal, the decimal have a recurring digit. That is, the decimal repeat indefinitely. So if, for example, we have 1 divided by 3, which we know that is 0.3333, goes on indefinitely. Here, we're going to approximate it to be 0.3 and put a dot on top of the first digit. Here we add a dot or a bar above the recurring digit. This is to show us that the number 3 is repeating, keep reoccurring indefinitely. Now, if we take a larger number, 41 divided by 70, we know the answer here is 0.57142857142, and it goes on indefinitely. Here we can see that 8 is repeating. From the 8, 57142 is repeating. So what we do approximately is, so we have equals to 0.58557142. Then we now put the dot on the 8 and the 2, the first and the last digit of the recurring numbers. Next, we'll be looking at irrational numbers. Irrational numbers cannot be written as a fraction. Their decimal goes on forever and ever without repeating. And the example we have of an irrational number is your pi, square root 3, and your Euler's number. Our Euler's number, the value of our Euler's number is e exponential e 2.71281, and it goes on forever, never ending, never terminating. So rational numbers are non-repeating and non-terminating. Next, we look at real numbers. Real numbers include all the rational numbers and the irrational numbers. All numbers on a number line, including both the rational and irrational numbers, are called real numbers. Basically, if it can be represented on a number line, it is a real number. Examples of a real number is your -2, 0, 3/4, your pi, and your square root 5 are all examples of a real number. One of the properties of a real number is the addition and multiplication of a real numbers are commutative. That is, the addition, the plus, and the multiplications of real numbers are commutative. For example, if we have two real numbers, A and B are both integers, so the addition of A and B is equal to the same as B plus A. So if, for example, our A is 3, our B is 7, is the same or is equal to 7. B is 7 plus 3. So here we have 10 equals to 10. So you can see the addition of the two integers, 3 and 7, all result to the same answer, irrespective of their different order. So here we can say that the addition of real numbers are commutative. The two integers, A and B, 3 and 7, added together in different orders, did not affect our result. So as I repeat, the addition and multiplications of real numbers are commutative. What about the multiplications? So if we have 3 multiply 7 is equal to 7 multiply 3. Our answer is what? 21. And here I said the answer is 21. So you can see the two integers, when they are multiplied together in different order, did not affect our final result. So here we can say that the multiplications of real numbers are commutative. So the addition and multiplication of real numbers are commutative. Next, we shall look at complex numbers. Complex numbers go beyond the real numbers. They include the real part and the imaginary part. So as you can see, the complex numbers are of the form A plus B I, where our I square is equals to what? Minus 1. So I is equals to the square root of minus 1. So our example, as you can see, is 3 plus 4i, where our I is the square root of minus 1. And the addition and multiplications follow the same rule as a complex number. Also, another property of a complex number is that the conjugate of a complex number, A plus BI, is A minus BI. So this, the conjugate of a complex number, A plus BI, is A minus BI. Let's do a quick recap with a diagram to show how all these types of numbers fit together. The natural numbers are inside the whole numbers, and the whole numbers are inside the integers. The integers are inside the rational numbers. The rational numbers and the irrational numbers combine to form the real numbers. The real numbers now and the imaginary numbers makes up the complex numbers. Everything is connected. It is like a big family of numbers, and that is it. Now you know the different types of numbers and how they relate to each other. If you enjoyed this video, please give it a thumb up and subscribe to my YouTube channel. And please hit the notification bell for more fun mathematics lessons. Do you have any questions or suggestions for future topic? Drop them in the comment below. Thanks for watching and see you next time.